Hello friends, can I call you friends? Yes, 10 standard very important stage. Do you feel very important? Yes, you are a very important person for this entire year. Maybe in the beginning itself, I wish you all the best. Today, I am here for geometry. And typically, what is the attitude for geometry? Some like it, some don't. Do we have a choice? No. So what do? We try to like it. How? Maybe by taking baby steps. And the very first step we are going to take is similarity. What comes to your mind when I say the word similar? Could be same? Yes. What else? Don't we say that I have got a dress similar to this? Yes. For example, maybe years later, if you want to build your dream house, or could be your own dream bungalow. Yes, you are going to tell civil engineer or architect that this type of house I want. Then what do? They draw the sketch of your house in neat and systematic way and gives you blueprint of the house. Yes, maybe some of you are getting it or some of not, that how similarity is used in our day-to-day life. It's okay. Let's begin with something which we have already studied in the previous classes. Geometrical figures. Which geometrical figure comes to your mind when I say triangles? Yes. What is the area of the triangle? Half into base into height. Yes. And which are the types of the triangles do we have? Right angle, obtuse angle and acute angle, which are based on angles. And what about the sides? Isosceles, scalene and equilateral triangle, which are based on sides. Just draw these triangles. Can you identify these triangles? I think so as 10 graders. First one is right angle triangle. When I say the word right angle triangle, we need to put this symbol. We can't just assume it as right angle triangle. Name it as triangle DEF. Can we identify where is the height and where is the base? Height would be the perpendicular height. So D is the height of the triangle DEF. And what is the base? EF is the base. When we turn this triangle, then EF would be the height and D would be the base of the triangle. We can see the two altitudes inbuilt in this triangle. Can we identify the third one? Yes, third one from vertex E perpendicular to the hypotenuse DF. I will draw it with the dotted lines. This is the third altitude. Now, what about an obtuse angle triangle? We name it as triangle PQR. What is the height and what is base? QR is the base and what is the height? Do you think PQ is the height of the triangle? Does it look like an altitude? No. So we draw the height from vertex P perpendicular to the base. We extend the base QR. First we extend the base. Then we draw the perpendicular from point P to the base QR. A is the height of the obtuse angle triangle PQR. And let's move on to the third one, our favorite acute angle triangle. We name it as triangle ABC. Can we identify the height? We draw the height from vertex A perpendicular to the base BC. BC is the base and AF is the height of an acute angle triangle. Now let's take the ratio of the areas of two triangles. We know the formula of area of the triangle is half into base into height. We take the two triangles, area of triangle DAF and area of triangle PQR. Area property of triangle. Area of triangle DEF upon area of triangle PQR. We know the formula half into base into height. EF is the base and D is the height. And here QR is the base and PA is the height of triangle PQR. Then what would happen? Half would get cut and what we are left with? Product of their corresponding heights and corresponding bases. Then A1 upon A2 equals to B1 H1 upon B2 H2. This is the area property of the triangle. Ratio of the areas of two triangles is equals to the product of their corresponding heights and corresponding bases. Now let's see the sub-properties of this area property of triangle. What would happen if B1 is equals to B2? Suppose B1 and B2 would be 4 and 4 centimeter and 4 centimeter. Then what would happen? Both would get cut and what we are left with? We are left with corresponding heights. Let's see it. First sub-property of area property of triangle. If B1 equals to B2, then A1 upon A2 equals to H1 upon H2. And similarly, if H1 equals to H2, then ratio of the areas of two triangles is equal to their corresponding bases. If H1 is equals to H2, then A1 upon A2 equals to B1 upon B2. And what would happen if B1 bases are also equal and heights are also equal? Both would get cut, and what we are left with? 0? No, 1. Third property, if H1 equals to H2 and B1 equals to B2, then A1 upon A2 equals to 1, or A1 equals to A2. These are the three sub-properties of the area property of the triangle. Just go through this and we will go with the next one in the next video. If you like the video, then please do like, share and subscribe to my channel. Thank you very much.